Hello everyone. So in today's video of chapter thermodynamics, I will be talking about Hess law of constant heat summation and spontaneous process. Hess law of constant heat summation. This law states that overall the enthalpy change for a reaction is equal to the sum of enthalpy changes of individual steps in a reaction. The enthalpy change for a chemical reaction is same regardless the path by which the reaction is occurring. Hess law is a direct consequence of the fact that enthalpy is state function. Enthalpy change of a reaction depends only on its initial and its final state, not on the path which reaction is taking. To determine overall equation of reaction, reactants and products are in individual steps are added or subtracted like algebraic entities. For example, if you are considering the synthesis of ammonia, in the first step, gaseous hydrogen will combining with nitrogen, which is also gaseous, to give you N2HO, which is gaseous, and enthalpy change in this is 95.4 kilojoule. In the second step, N2H4 is combining with hydrogen to give you ammonia, and in this step, enthalpy change is minus 187.6 kilojoule. So, the enthalpy change for the formation of ammonia, I am going to combine the equation number 1 and 2, and I will be getting hydrogen plus nitrogen to give me ammonia, and the enthalpy change will be minus 92.2 kilojoule. The application of Hess law is it is useful to calculate the enthalpy changes for the reactions with their enthalpy being not known experimentally. Now, the next thing we are learning here is spontaneous or irreversible process. Spontaneous processes have a natural tendency to occur and do not require any external influence for their occurrence. What all are the key points of spontaneous reaction? Number 1 is it occurs of its own, does not require any external agency to occur. It proceeds in one direction and cannot take place in the opposite direction unless external stimulant is present. Its third point is spontaneous process can be rapid or slow, or spontaneity is not at all concerned with the rate of reaction at all. And the fourth point is the processes continues till equilibrium is reached. The natural processes or spontaneous processes tend to occur in a direction which lead to attain the equilibrium. Now, energy and spontaneity. The spontaneous reaction takes place in a direction in which the energy of system is getting lowered. It is accompanied by the release of energy. The reaction between NaOH and HCl is exothermic. It is a spontaneous reaction. On the other hand, like ice is melting spontaneously above 0 degrees Celsius by absorbing heat from surroundings. It is endothermic. Likewise, sodium chloride is dissolving spontaneously in water by absorbing heat from the surroundings. It is spontaneous reaction. So, these are the endothermic reactions which are spontaneous. So, it is therefore very much clear by these three examples that endothermicity or exothermicity is not a sufficient criteria to decide the spontaneity of the reaction. We need some other factor to describe the spontaneity of a reaction. So for that, let's talk about first entropy. What is entropy? For example, let's assume in solid state water molecule and the water molecule in liquid state. In solid state, water molecules are very much arranged in a definite order. because they are solid in nature. In liquid state, the molecule will start moving randomly. They will be disordered in the liquid state. And when we are transforming this liquid state into gaseous state, there would be more randomness. There is more disorder in case of gaseous. So we can say during melting of ice or vaporization of liquid of water, the disorder or the randomness increases. And the disorder or randomness is measured in terms of entropy. And this entropy is denoted by capital S. Greater the disorder of the system, greater its entropy. Melting of ice and vaporization of water liquid shows the disorder which is increasing. So the entropy of system is also increasing. It is passing from solid to liquid and liquid to gases. In both processes, entropy change delta S is greater than 0. For example, if you are taking iodine which is solid and you are dissolving iodine in water to get aqueous iodine solution, solid iodine having arranged molecules in a very orderly way, whereas in case of dissolved iodine solution you will be having water iodine molecule are moving here and there, so order is not even there. Randomness is created in the solution. So here what is happening, delta S is positive because the disorder is increasing, the randomness of the molecule is increasing. So this is how we can understand entropy. Now quantitative definition of entropy. Entropy is a measure of the molecular disorder or randomness. The entropy of a system is equal to the amount of heat transferred or Q rev to its reversible manner divided by the temperature which is taken in Kelvin. And we can say delta S is equal to Q ReV upon capital T. And capital S is expressed in Joule per Kelvin. Entropy is a state function, does not depend upon the path, it is only depending upon the initial and the final state of the system. If heat is added to the system, the molecular motion increases owing to the increase of their kinetic energies. So the result in increased molecular disorder, so entropy of the system will also increase. So delta S is proportional to Q reversible. The effectiveness of addition of heat to more increased randomness depend upon the temperature. If a certain amount of heat is added to the system which is already at the higher temperature, then the disorder caused is lesser than the cost by adding same amount of heat which is added to the system which was there at the lower temperature. Thus, delta S relates reciprocally to the temperature at which the heat is added. So, the next thing which we should look into is entropy and spontaneity based on second law of thermodynamics. Let's talk about some examples like the entropy increases when ice melts above 0 degrees Celsius or water is converting into vapor form at 100 degrees Celsius. Both are spontaneous processes. One spontaneous reaction is decomposition of hydrogen peroxide into water and oxygen gas. Entropy increase due to the formation of oxygen gas because due to the formation of gaseous oxygen, the randomness is increasing. That is why entropy is increasing by the decomposition of hydrogen peroxide. One more example is hydrogen is combining with oxygen gas to give you liquid water. Here what is happening, the entropy of system is decreasing because the gaseous state is transforming into liquid state, but the reaction is spontaneous. Now for that we will learn second law of thermodynamics, which we will do in next video. Thank you.